Okay, this problem says that you're riding a Ferris wheel and that your height with respect to time can be modeled as a sinusoidal function. So here we have a Ferris wheel loading all the people. When it starts the ride, you're seated in the position shown. So you're not quite at the bottom of the ride and you're not quite at the top of the ride. You're somewhere in between. The Ferris wheel is going to turn counterclockwise, but whether it turns clockwise or not, when you're on the ride, you're going to be starting to increase in height, and then you're going to decrease. So I've made a horizontal and a vertical axis. The problem says let t be the number of seconds since the Ferris wheel started. So our height's going to vary with respect to time. So our x-axis is the number of seconds after the ride starts. And we'll call that t. And our vertical axis is going to be our height. So our height is going to change with respect to time. So I'm just going to call this our height. And it's our height in feet. Now we're going to have a low and we're going to have a high. So we're going to have our lowest height and our highest height while we're on the ride. So obviously when we're on the bottom, or at the bottom of the ride, that's going to correspond to this value right here. When we're at the top of the ride, that's going to correspond to this value right here. And the difference between the lowest and the highest height is going to be that diameter of our Ferris wheel. So this distance between the low and the high is the diameter. And the diameter of the wheel is 98 feet. So I'm going to jot that down, 98 feet. So from our lowest value to our highest value, we've got a change of 98 feet. It takes 48 seconds to get to the top, 2 minutes to go all the way around to your starting place. You find yourself 3 feet off the ground at the lowest point. At the lowest point, you find yourself 3 feet off the ground. So that tells us right here, our lowest point is 3. And then if we've got 98 feet to the highest point, 3 plus 98 is going to be 101. And then somewhere in the middle here, we've got our midline. So somewhere right there in the middle, we've got our midline. Okay, so what would that value be? Well, there's a couple of different ways that we can figure out what that value is. I would probably take the 98 and cut it in half, to be quite honest. So if I cut this in half, this is going to be 49, and then this is going to be 49. Because that's going to be the radius of the Ferris wheel. So 3 plus 49 is going to be 52. 52 plus 49 gives us the 101. So if that makes sense. So I'm going to give you a nice little visual here. I hope you find it to be a nice visual. See, that's the 49. So 3 plus 49 is 52. So we've got our midline, we've got our min, we've got our max. Now we need to start filling in that horizontal timeline. So the horizontal timeline It says that it takes, I'm just going to start using all sorts of colors here. It takes 48 seconds to get to the top. So to the top is our maximum height. So 48 seconds, I'm going to say that this distance right here is 48 seconds. It takes 48 seconds to get all the way to the top. So there's 1 point. So there's my maximum. I know that after a full revolution, I'm going to be at 101 feet again. And it takes, let's look at this, 48 seconds to get to the top and 2 minutes to go all the way around the Ferris wheel. So 2 minutes is the same thing as 120 seconds. So if I take 48 and I add 120 seconds, let's see, that's 50, 100. Let's say 120 seconds is right here. I just really have a feeling that my tick marks are just not as perfect as I want them to be. So did you see what I did there? What I did was I cut it in half. So, and I don't even know why I wrote 120 seconds there. Let me fix it. 48 plus 120. So this distance is going to be 120. So 48 plus 120 is 168. So that's the number I should have written here. Now I'm going to cut that in half. I don't know, I'm eyeballing it. That looks maybe in half. And then I'm going to cut that in half and that in half. So really what I've done is I've taken 120 and I'm dividing it into 4 intervals. 4 goes into 120 30 times. So 40 plus 30 seconds would give us 78 seconds. Plus another 30 seconds would give us 118 seconds. Plus another 30 seconds, oh boy, I'm really testing my math skills here, would give us 148, and something happened wrong here. 48 plus 30 is 78. 78 plus 30 is 108. I told you I was testing my math skills. 108 plus 30 is 138. 138 plus 30 is 168. Hooray. Okay, so hopefully if you rewind this, you'll find my mistake too when I added that 30. Sometimes you just have problems adding. So 48 seconds it takes to get to the top. We know that 120 seconds later, we're going to be at the top again. Halfway between that 120 seconds, we're going to be at the minimum. Halfway between the maximum and the minimum, we're going to be at the midline, And there's our curve. So we know that our midline, I'm going to do everything else now in this bright green. We know the midline is at 52, so D is 52. We know the amplitude. Your amplitude is your distance from your midline to your max or your midline to your min. In either case, we know that that value is 49. So A is equal to 49. I know C for cosine. I'm shifting my cosine curve. I'm going to show you a really cool picture here. I'm shifting my cosine curve watch. Normally the cosine curve starts at what? When x is 0. So watch this. So when x is 0, you go up to your maximum right here. And then you go over to your maximum and you draw your cosine curve. Let me get that back. All we're doing is we're taking that cosine curve and we're shifting it to the right. That's a phase shift, right, 48. So we're going right 48. So C is going to be 48. and that's because we're going right 48 seconds to get to the maximum. And last but not least, our B value. B is equal to 2 pi divided by the period. And the period is 120 seconds. So 2 pi divided by 120. You can make that pi over 60 if you'd like, but I'm fine with it being 2 pi over 120. So we're going to plug all these values in. To our general equation here. So in place of D, we're going to have 52. In place of A, we're going to have 49. And then this is the cosine curve because we're graphing from max to max. The B value is 2 pi over 120 times the quantity. I'm going to make this value T for time because I used a T over here. So I just want to stay consistent. T minus, and our C value is 48. And that's the function for the Ferris wheel. Now, it's going to ask you these other questions, A, B, C. A is the actual particular equation for this cosine, which is a sinusoidal function. B and C, once you have this equation, you use your calculator for that, and that would be another video or something I can show you in class. But this right here, if you can get this part, the calculator part is going to be a breeze. So practice this part, finding out how to get all your parameters, A, B, C, D. Rewatch the video if you need to. Try not to focus too much on this circle because I think that can be confusing. Go back through and watch the video if you need to, and use this part that I showed you over here. Use this part as a way to kind of reason out what's happening with your height, because your height is just going up and down. Don't think of it as going around and around. Just think about your height going up and your height going down, your height going up, your height going down. And maybe that will help you with this Ferris wheel problem.